Well, let's talk over some of these readiness assurance process quiz results. Number 9 was one that certainly a lot of individuals had problems with, and let's just start there. So what will happen to a typical isoquant if robots become increasingly good at doing manual and mental labor? And isoquants might become steeper, A, they might become flatter, B, they'll become a negatively sloped straight line. Isoquants will not change, but movement will occur upward on the curve. So let's think about this. The answer has to be B, isoquants will become much flatter. All right, the next one people had problems with was D, and I don't think teams had so many problems as individuals did, but let's just talk through number 10. This is another application of the equimarginal principle. When costs are at a minimum, the ratio of the marginal product of labor to the marginal product of capital is less than the wage rate divided by the rental rate of capital. No, they're actually equal at the optimum. That's the tangency between in that long-term production. It's the tangency, the isoquants, Q equals Q bar, it's sort of shorthand. There's a bunch of different isoquants as we move to the northeast. There's more output, and which combination of capital and labor would we choose? Well, we choose the one that minimized costs, and so we have these isocost lines, and there's a bunch of isocost lines. Their slopes is the wage rate over the rental rate of capital, and again to the northeast is more cost. Well, we want to cost minimize, so the least we can spend to make Q bar, some constant amount of quantity, constant amount of output. The lowest cost input combination would be the one where the isoquant is just tangent to the isocost line. So they'd be equal. Marginal product equals marginal product of labor equals marginal product of capital. That's just saying that the marginal rate of technical substitution is equal to 1. That doesn't make any sense. That would only be an optimum if the wage rate and the rental rate of capital were exactly equal. Extra output we get from the last dollar spent on an input must be the same for all inputs, and D is just as absurd as B. But think about C. Again, it's another equimarginal principle example. And here, think about if this weren't true, if one factor gave us a lot of output per dollar spent on that factor, and another factor gave us a little bit of output per dollar spent on that output. Well, we'd spend less dollars on the factor where we're just getting a little bit of output for that dollar spent, and move it over to the factor where we're getting a lot of output for the dollar spent on that factor. And as we did that, the marginal product for the one where we're adding that factor would fall. The marginal product from of the factor we're using less of would rise, and we'd keep adjusting until those were just equal, or if we were at a corner solution where we're just using all of one factor and none of the other. So C is the only answer there. So the framework that this question is asking you about is the long-term production framework. And here we map labor and capital, both are variable in the long run. And the tool we use are these isoquants, and these are very similar, as I mentioned in class, to indifference curves in utility theory, but instead they're isoquants. Q equals 10, say. They're all different combinations of capital and labor that could produce 10 units of output. Now, what would happen if robots, we'll just call capital robots. What will happen if robots become better able to do everything, the physical and mental tasks. And basically, one robot would become equivalent to many, many more units of labor. And what that means is, remember the slope tells us how many robots we're willing to give up for 1 unit of labor. We'd be willing to give up many fewer robots for 1 unit of labor. And what that means is that isoquants become flatter. And again, we need a lot of labor to compensate for losing 1 robot. Whereas before we might have just needed a little labor to compensate for losing 1 robot. So back to the question. All right, we have this other set of problems. Let me just look on my notes to see which ones anybody had problems with. Looks like 11 and 13 were the 2 that gave individuals fits, and maybe some teams as well. Let's talk through 11. The following is true about point A. So we're at point A. For which a firm with isoquant I1, firm with a I1 isocost curve. Okay, sorry. So there it is. I wonder, I guess I for isocost makes sense. All right, what do we know? Capital is relatively more expensive than labor. We don't have really units, so we can't really say. The firm is minimizing the costs of production. Yeah, that's true. Notice again we're at a tangency at A. We're at a tangency between A and I1, so certainly B is true. Let's just rule out labor has a lower marginal product than capital. Again, we don't have units, so it's hard to tell. All of the choices are true. No, A and C are not necessarily true. Without units, you can't really tell. All right, so 13. So it has to be B. The marginal cost curve slopes upward due to. Turns out, the marginal cost curve slopes upward in the short run. That's a short run feature of the marginal cost curve. In the long run, it may slope up or may not slope up. Anyway. This is a feature of diminishing returns. Marginal cost and marginal product are very closely related, and we can show, and we will show, that actually, I can just show you now. Marginal cost is defined as the change in total variable cost, or the change in total cost too. But since only labor in these models is changing, total variable cost is the same as the change in total variable cost is the same as the change in total cost. Fixed costs aren't changing, right? They're fixed. Anyway, we can rewrite this as since there's only one variable factor. Notice that the change in total variable cost is the wage rate times the change in labor hired. So that's one way to write down the definition of marginal cost. And marginal product is defined as the change in output per change in variable factor, labor. And notice that looks a lot like this one. In fact, we can, given that this definition for marginal product, the marginal cost is equal to the wage rate times 1 over the marginal product. So marginal cost is essentially the inverse of the marginal product scaled by the wage rate. All right, I think there was another one that students and teams perhaps as well had trouble with. Let's move on to the next page. It's 15, 17, and 18. You know what? Let's save this for another screencast, just so you can take a break here.